problem, we're going to do it the way we've been doing it. We know that pi is 180, and our job is to figure out what is 200. So these two are the same, and we're trying to figure out what would be the same as 200. So we'll cross multiply and divide. Now we need to reduce, so we can take 10 out of both, and then we have 20 over 18, which is 10 pi over 9. So the answer to the question, 10 pi over 9. Number 2, we're going to do the same thing backwards. So this is a radian, and we're going to change it into a degree. So we know that pi is 180. Pi is 180 degrees. So I'll divide that by 3. 180 divided by 3 is 60. And then I'll times it by 5, and that's 300 degrees. So we're just putting 180 in for the pi. Number 3 is a calculator question. So I'm going to take my calculator out, and since we've been messing around with it in class, I'm going to double check my mode to make sure I'm in degrees. So press mode, go down and highlight degrees and press enter. Now I'm all set. So 187 second apps degree, 19 second apps minute, and 46 alpha plus gives me my seconds, and I got 100, it says round to the nearest thousandth, so 187.329. So there is my decimal degree for that big number that they gave me. Number 4. My job is to figure out what the radius is. I need to figure out what the radius is. So when I see a picture like that, and I see this over here marked, that's an arc length. And so the first thing that pops into my head is arc length equals radius times radians. Kids, you can't go wrong with that. If you can remember that, you'll get it right. So 32.7 is the arc length. The radius is, I don't know, that's my X or my R, don't know it. And my radian measure is 1.6. Mrs. Ford, how do you know that's a radian measure? Because it doesn't have a degree mark. If it's a degree, it will have a degree mark. If it doesn't have a degree mark, then it's a radian. So that is a radian measure. So I'll simply divide both sides by 1.6. And it tells me to round to the nearest thousand. So 32.7 divided by 1.6 is 20.438. Thousand is 3 decimal places, so 20.438. draw the whole thing. You won't have time to draw the whole thing, so you're gonna do that. But here's our setup. Here's north and south and east and west. So south, southwest is obviously gonna be down here, south and west. So let's split south and west, and that would be southwest. Now, I can do two different splits. I can split this one, and I can split this one. Which one do I want if I want south, southwest? Here's southwest. South, southwest would be this one. So this is the split that I want. This is south, southwest. Now remember that a quadrant is 90. So to this far, that would be 180, 2 quadrants. But I have to go a little bit more. Now how much is that? Well, if I went all the way to the southwest line, that between my fingers would be 45, half a quadrant. But I'm only going half of that 45, so this little bit is 22.5, half of the 45. So what's my answer? Well, 180 and 22.5 would be 202.5. So that is the degree measure, or the angle measure, for that angle. All right, last one. Draw a course of 312 degrees. So we're using the same compass setup. 312 degrees. I'm going to start up here at 0. And this is 90, and this is 180, and this is 270. So won't 312 be in here somewhere? So you're going to come all the way around and mark that angle 312 degrees. That is your quiz. And you remember all the other quizzes that we've taken all year. The quiz we take in our next class period will look just like this. The problems might be mixed around, there'll be different numbers, but this is what is on the quiz. Okay. All right, let's get our notes out, and we're going to pick up where we left off. And we got different places in the different classes. So feel free, if you already have notes completed for what I am going to talk about here, just go ahead, fast forward, skip ahead, unless you want to watch it again. But not every class got as far as some did, so I'm going to just start where the slowest class left off. So that would be on page 33 of our notes. Problem 4, which we are evaluating with our calculator. And we still need to do problems D, G, and H. So D, G, and H are the problems we need to do. All right? So first thing I notice about D, G, and H is that there is no degree mark. So I am going to go to mode. I'm going to go down to radians and highlight it, because the angles I'm going to be putting into my calculator for problem D, for example, which is cosecant 5 pi over 16. That's a radian measure, so I have to tell my calculator, okay, we're going to be in radians. So I highlighted radians, hit enter. Now I'm ready to go. I don't have a cosecant button, either do you. So to get a cosecant, we're going to do 1 divided by sine, because that's what cosecant is. Look at your green sheet. 1 divided by sine. And then I'm going to type, literally type, 5 pi divided by 16. So 5 pi, which is second caret, it's over here under your clear button, divided by 16. And the answer you should get is 1.2027. 1.2027. If I round to the nearest 10,000th, which is what we usually do with our trig functions. Okay, G says secant 18 pi over 23. All right, that's easy enough. We can do that. Secant 1 divided by cosine. Secant is 1 divided, it's the reciprocal of the cosine. 1 divided by cosine. 18 second pi divided by 23, negative 1.2891. There is your secant. And finally, we want the cosecant of 2. Well, cosecant is 1 divided by sine. So 1 divided by sine, 2. Just 2. And the answer is 1.0998. 1.0998. Okay. Part 5. Now, this is where we really have to have our thinking caps on, and you might want to have your green sheets handy if you don't have everything memorized already. Part 5 says there is an angle out there, and his cosine is 1/2. I don't know what that angle is. Remember, theta is like an x. I don't know what that angle is, but I know that its cosine is 1/2. So you remember from our last class, or our last couple classes, that when we are drawing our triangle, and we're going to draw a triangle for every problem, when we're drawing our triangle, we set up our coordinate axis system, start at the origin, come out and down like this. That is what our triangle is going to look like. The angle is always at the origin. So there's messy theta. There's my angle, theta, right there at the origin. Now, what do I know about my triangle? Well, remember, cosine, so toa is adjacent over hypotenuse. That's what cosine is. So I know that my adjacent side is 1 and my hypotenuse is 2. Now, if you look down the bottom of your read sheet, you think about what we talked about yesterday, this is one of my special triangles. If this is a 1 and that's a 2, this guy is a root 3. This is a 30, 60, 90 triangle. When you see sides that are 1, 2, and root 3, that's a 30, 60, 90 triangle. And the side, or excuse me, the angle that is across from the root 3, look at your green sheet if you don't remember, the angle that's across from the root 3 is a 60. So the answer to the problem is 60 degrees. We're looking for the angle that has adjacent over hypotenuse as 1/2, and that angle is 60. This one is tricky. I will not do that to you on test day or quiz day. This is the rationalized form of 1 over root 2. So again, I don't want you to worry about that. That I won't give you one like that. It will look like this, 1 over root 2. Because if you multiply top and bottom by root 2, that's what you get. But don't worry about that. This is the problem. Alright? So I'm going to draw my triangle, just like I did before. Here's my angle, right there at the origin. Sine is opposite over hypotenuse. So, opposite over hypotenuse. So this is a 1, and this is a root 2. Now, if we are doing these problems by hand, the angle is going to be special. The triangle is going to be special. So it's either going to be a 30, 60, 90 like that one was, or it's going to be a 45, 45, 90. And that's what we have here. Because again, look on your sheet. The sides of a 45, 45, 90 are 1, 1, and root 2. That angle is 45 degrees. 45 degrees. We are doing what we did yesterday, but we're doing it backwards. You're building the triangle and then finding the angle. Okay, so let's see. Cosecant is 2. Now, all of your functions are fractions, so if you want to think about that as 2 over 1 for a moment, you can. Cosecant is the reciprocal of the sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Cosecant is reciprocal of sine. So I'm going to draw my triangle. Here's my angle. The hypotenuse is 2, and the opposite is 1. So again, you always, if you don't have a calculator, if you're not allowed to use a calculator, then you are going to have a special triangle. If that's a 2 and that's a 1, this is a root 3. What angle, this is a 30, 60, 90, these are the 30, 60, 90 numbers. What angle is across from the 1? Across from the 1 is a 30-degree angle. Don't stare at me with confusion. That is on your green sheet. You are memorizing that in a 30, 60, 90, across from the 30 is a 1. Tangent equals 1. And again, these are always fractions. So feel free, instead of writing 1, feel free to write 1 over 1 so that you can see a fraction. Tangent is opposite over adjacent. So 1, 1. Opposite adjacent. This is a 45, 45, 90 triangle. You have a 1 and a 1 and then a root 2. 45, 45, 90 across from the 1 is a 45. And, excuse me, got the hiccups. That is the answer to the question. Theta is 45 degrees. One more time, the only triangles you have to be able to do by yourself without a calculator are those 2 special ones. So learn those sides. Okay, secant is 2 over root 3. So again, we got to remember what secant is. Secant is the reciprocal of the cosine. So if cosine is adjacent over hypotenuse, then secant will be hypotenuse over adjacent. So the hypotenuse is 2, and the adjacent is root 3. You need to recognize those numbers. That's one of your special triangles, and the other side is 1. What angle is across from the 1? 30 degrees. And there you go. That's the answer to the question. One more of these. Cotangent is root 3 over 1. Cotangent is the reciprocal of the tangent. Since the tangent is opposite over adjacent, the cotangent will be adjacent over opposite. So the adjacent side is root 3 and the opposite side is 1. You should recognize that triangle or look on your paper. This hypotenuse is 2. That is a 30, 60, 90 triangle. Which side is across from the, which angle is across from the 1? 30 degrees. So the answer to the problem is 30 degrees. Same triangle as this one. Different problem, but it ended up, oh wow, it's the same one as that one too. They're all exactly the same. Triangle. Which isn't uncommon because we only have 2 triangles total. So of course we're going to be generating the same picture over and over. All right, get your calculators out. Now we are going to not be doing 30, 60, 90s anymore. Now we're doing weird random triangles, and it's okay because we have our calculator. So this is not going to be a problem. It's perfectly okay. We can do anything with our calculator. All right, so here are the first 3. Solve for x. Okay, first thing you need to do when you look at your picture is figure out what's opposite, what's adjacent, what's hypotenuse. This is the angle you use. Use the angle they gave you. They gave me this angle right here. So I'm going to use that angle to determine that the 10 is opposite and the x is the hypotenuse. Now, I'm going to write an equation. The equation I write is always going to be a sine, a cosine, or a tangent. All right? Because I'm going to use my calculator, and those are the only functions that I have actual buttons for. So I'm going to do a sine, a cosine, or a tangent. And to decide which one I'm going to use, I'm going to look at the 2 sides that I have. The sides in the problem are the opposite and the hypotenuse. This guy, I know he's adjacent, but I don't have anything labeled there. So I'm not using him. I'm using opposite and hypotenuse. So let's remember SOHCAHTOA. Which function, sine, cosine, tangent, uses the opposite and the hypotenuse? Isn't it right here? That's sine. So the equation I'm going to write, I've now figured out I'm going to use sine. So the equation I'm going to write is sine 28 equals opposite over hypotenuse. Now, when you figure out you're going to use sine or cosine or tangent, whatever you're using, the angle gets attached to that. So sine 28. the angle gets attached to whatever you picked, sine, cosine, or tangent. And then that will equal, in this case, opposite over hypotenuse. To solve this, I am going to multiply both sides by x. That will get rid of the fraction, so x. And then I'm going to divide by sine 28. I'm going to divide by this, sine 28. And then I'm going to type it in my calculator. Caution. See that right there? That's a degree mark. So my calculator needs to be in degrees. So mode, go down, highlight degrees, press enter, and then type in 10 divided by sine 28. And your answer is 21.30. I don't have any rounding instructions there, but let's pretend it's hundredth, I guess. We'll just make it 21.30. Done. Not bad. Okay, let's look at the next one. So you're going to write an equation, but before you can write your equation, you have to figure out which sides you've got. So here's your angle. This is the adjacent, and this is the hypotenuse. So you're going to pick a function, and the one you're going to pick is the one that links adjacent and hypotenuse. So which one is that? Cosine. So cosine angle, remember, you always attach the angle to your sine, cosine, or tangent. So it's going to be cosine 13 equals adjacent over hypotenuse. Will times by x and divide by cosine 13. Cosine and 13 are attached. Okay, they're hooked. So the whole thing comes cosine 13, 4 divided by cosine 13. And our answer is 4.11. If I round to the hundredth, 4.11. Okay, hopefully this is starting to make some kind of sense to you. The first thing we're going to do is figure out which sides we've got. So here's your angle this time, it's up here. So this side is the opposite, and this side is the adjacent. This is the hypotenuse, but I'm not using the hypotenuse because I don't know anything about it. These are the only two sides that are labeled. So those are the sides I use. So which function uses opposite and adjacent? Tangent. So tangent 52, remember, the angle always gloms on to the function. So tangent 52 equals opposite over adjacent. So I'll multiply the 5 over to here, and then I'm done, I'm ready. Type it in, 5 tan 52. And ooh, this is gonna be 6.40. It's 399, so I'm gonna have to round it up to 40. So 6.40. Okay, we have a couple more of those. If you know what you're doing, feel free to mute me and do them on your own to see if you can get the right answer. If you're not sure what's going on yet, let's work through it. All right, so here we are on D. Do you remember the first thing you need to do? Figure out which side you got. So here's my angle. So this would be adjacent, and this would be hypotenuse. So what function do I use if I have adjacent and hypotenuse? That's a cosine. So cosine 17 equals x over 10. Multiply by 10. And that's it. I'm ready to type it in. So here we go. 10 cosine 17. And I got 9.56. Last one in this section. We still have a little bit more to go, but the last problem in this section, here we go, let's make it good. There's your angle. This is obviously the hypotenuse, and this is the adjacent. So once again, I'm going to be using cosine because cosine is adjacent over hypotenuse. So cosine is 5 over x. Adjacent over hypotenuse. So I'll multiply the x over and divide. Remember, you can't divide by COS. You can't divide by 63. They're glued together. So you divide by the whole shebang, cosine 63. 5 divided by cosine 63 equals 11.01. So your hypotenuse is 11.01. Now, I know you're looking at the next page and you're kind of freaking out because it's word problems, but believe it or not, if you're starting to get the hang of that, you're going to get these. Because the only difference is, with the word problems, you have to draw your own picture, okay? So let's look at number 1 and let's see what this picture, it's going to be a triangle. You're going to be drawing a triangle. Let's look at it and see what we got here. So we've got a tree, and we've got a squirrel in the top of the tree. Here's the ground. The tree is standing straight up. When we do these, we assume that the tree is standing straight up, or the pole is standing straight up, or the cliff is standing straight up. We just make that assumption that we've got a handy-dandy right angle. Okay, so I got a squirrel up there. The tree is 52 feet tall, and the squirrel is looking at an acorn or something on the ground. So down here is the nut. So the squirrel is up here and he's looking down here at the nut. The angle, his angle of depression is 23. Now, this is where we can get confused if we're not listening and paying attention and totally focused. The angle of depression is not this. The angle of depression is the angle that you look down through. So look straight out and then look down at something. This is looking straight out. This is looking down at something. That is your angle of depression. Well, I know what you're thinking. That's not even in the triangle. And you're right. But here's the good news. You learned in geometry that if two parallel lines are cut by a transversal, alternate interior angles are congruent. So it turns out that the angle of depression will always equal the angle of elevation. So think about it like this. You have a squirrel looking down at an acorn. If there's a bug in that acorn and he looks up at the squirrel, those angles are the same. The angle of elevation and the angle of depression are the same. So when you do these problems, let's not mess with that. Let's always mark our angle right here, because that angle can serve as both an angle of depression and an angle of elevation. So I'm going to put my 23 right here. Always. Always. Are you listening to me? Always. Your angle of elevation, your angle of depression, right there. Well, now it looks just like the ones we just did. So we're going to look at the picture. Oh, what are we trying to figure out? Find the distance from the nut to the base of the tree. That's X. That's what I'm trying to figure out. So here's my angle. This is opposite and adjacent. There's the angle, opposite and adjacent. So which function? If we have opposite and adjacent, we're going to use tangent. So tangent 23 equals 52 over x. Multiply both sides by x. And divide by tan 23. So x is going to equal 52 divided by tan 23. So we go to our calculator. 52 divided by tan 23. 122.50. Now, a little difference here. Because it's a word problem, we're going to label our answer. So it would be feet. So 122.50 feet is how far the nut is from the squirrel, or from the base of the tree, excuse me, the nut from the base of the tree. All right, let's get a couple more done here. B, now we have a lighthouse. Here's our lighthouse. And we have a seagull up here, that's a seagull, and he's looking down at a fish in the water. We know the seagull is 87 feet up, and we know that the seagull is 230 feet from the fish. What do we want to know? We want to know the angle of depression. Now, remember, that's what we want to know. Remember, our angle of depression is technically up here, but I don't want to mess with that. So the angle of elevation, the angle of depression, both go right here. Okay, that's it. That's your angle right there. Whether the fish is looking up at the gull or the gull is looking at the fish, the angle is the same. Okay, now if that's my angle, this would be the opposite, and this would be the hypotenuse. So what function am I going to write if it's opposite and hypotenuse? This one? So sine x equals 87 over 230. Right, now stop. I know this looks a little different, but remember, whenever you write a sine, you attach the angle to it. In this case, the angle is x. So sine x equals 87 over 230. These are not separate. There's nothing you can do with that, okay? In order to solve this, we need a new button on our calculator. Whenever you are finding an angle, you have to use one of your inverse buttons. Okay? So if you look right above your sine button, you'll see this. This is the button that finds an angle. These are the buttons that find an angle. We need that one because this is a sine problem. So to get your answer, you are going to type that button, and and then your fraction. So type second sine 87 divided by 230, and you should get your angle to be 22.23 degrees. So let's keep this straight. I only use these buttons if my angle is the x. If the angle is what I'm looking for, then I use these buttons. Okay. Okay. Not sure what's going on outside. All right. Next problem, C. We have to stop here shortly. We'll do one more. Problem C. We have an airplane up here, and he's flying into the airport. Okay, so the plane's up here, flying into the airport. The airplane is currently 5,000 feet above the ground, and the angle of depression is 17 degrees. Remember, we're always putting our angle of depression or elevation right here. Okay, what am I looking for? How far is the plane from the port? Right there. How far is the airplane from the airport? That would be that right there. All right, figure out your function. Are you going to use sine, cosine, or tangent? Well, this is opposite, and this is hypotenuse. So I guess I'll use sine. So sine 17, hook the angle to the sine. Sine 17 equals opposite over hypotenuse. Multiply by x and divide by sine 17. Now, am I going to use this button? Absolutely not. The only time I use that button is if x is right here. Is x right there? No, x is out here. So I use my regular sine button. 5,000 divided by sine 17. And I got 17,101.52 feet. Now, I know we have a couple more to do, and we'll do those next time, but I am going to assign the 4-2 homework. So 4-2 homework will be due on Monday or Tuesday. 4-2 homework will be due on Tuesday. And next time we're together, we'll do two things. We'll take our quiz, and we will do these last couple of problems here, and then move on to the next section. Okay, have a great day. Quiz next time.